Hello! Today we'll build a scatter chart in SciChart.js, two series on one surface with visually distinct marker shapes and colors, a sweep animation as the points appear, and zoom and pan interaction. We go from project structure to the code, then to what you see on screen. Each section matches a step in reproducing the example. The example is split across three files. HTML defines the page and the container element for the chart surface. CSS handles layout so the surface can fill the viewport. Chart logic lives in a single JavaScript module. One entry function that creates the surface, configures axes, prepares data, registers two XY scatter renderable series, and attaches zoom and pan modifiers. Markup and styles stay intentionally minimal so the sample is easy to reuse. What follows tracks that function in source order: surface and axes, data, each series, then interaction. The chart starts with SciChartSurface.create. That call returns SciChartSurface, the surface you attach axes and series to, and WASM context, which you pass to axis constructors, XyDataSeries, and point markers whenever the API expects it. Think of WASM context as the shared handle for creating chart objects. You do not need low-level WebAssembly knowledge to use it. Add numeric axes on X and Y. On Y, GrowBy adds modest vertical padding, so points are not flush against the edges of the plot area. The data range itself does not change, only the visible margins do. With the axes in place, define the arrays the scatter series will use. Both series share one X array with indices from 0 to 249. Two Y arrays are built from that X, different underlying slopes with pseudo-random noise layered on top, so you get one horizontal axis and two different patterns along Y. The noise is intentional. The chart looks like ordinary scattered data, not a perfectly smooth curve, which is closer to real measurements or typical operational metrics. Register the first series with XY scatter renderable series. Its data series is an XyDataSeries that pairs the shared X array with the first Y array. Ellipse point marker draws circular markers. Take the fill color from the shared theme so it stays consistent with the rest of the application. Keep opacity below 1 so overlapping markers stay readable. Use SweepAnimation with a moderate duration and fade effect enabled so the points appear in a sweep. The distribution builds up gradually instead of appearing all at once. The second series mirrors the first. Another XY scatter renderable series, an XyDataSeries, the same X array and the second Y array. Triangle point marker and a distinct theme color distinguish the two series at a glance, without relying on a separate legend or extra UI Chrome. Use SweepAnimation again with a positive delay so the first sweep finishes before the second begins. When you adapt this pattern, keep the series in the same order in source code as the order in which you want the animations to run. With both series registered, enable navigation with modifiers. Zoom pan modifier with enable zoom:true supports pan and zoom with the pointer. Mouse wheel, zoom modifier, zooms with the scroll wheel. Zoom extents, modifier resets the view to the full data range using SciChart's standard reset gesture. After you register the modifiers, call SciChartSurface.zoomExtentsParens once so the first view fits all the points. Together, these three modifiers provide pan, wheel zoom, and a reset to full extent in the running application. To reproduce this setup, keep the same sequence, surface and axes, one shared X and two Y arrays, two XY scatter renderable series with distinct markers and staggered sweep animation. Then, the three modifiers and an initial zoom extents. Replace the demo's synthetic formulas with your own data as needed. For full API details and more examples, see the official SciChart documentation and the samples linked from this project. Thank you for your attention. Goodbye.